All right. Hello, everybody on the internet. We are here at Ernie Barcelona. First time live since long ago, together with the front-end community. And I have the pleasure to introduce Paul Garcia today, who will be giving us a tech talk about ReactiveX. What is it and why should I bother using it? So we are at Barcelona headquarters. We are currently 6 people here, and more other people are coming. We have a 360 camera that we can try. Can any of you talk to see if people can see you?
Hello.
Okay. Yeah, it is working. It is working. Okay. So I leave the mic to Paul so he can do the intro and show us what he's going to present today.
Perfect. So let me start. Um, as Albert already said, this is about ReactiveX. I will be focusing on RxJS, but I think that the concepts are generic to any library. You could implement ReactiveX with Java, for instance, and I think that the basics are the same, just with different type of code. So, what exactly is Rx? ReactiveX stands for reactive extension. So basically, it's extending the current code to be more reactive. And I will split the topic in 3 key points. So it's a set of types to represent asynchronous data, which we will be calling observables. Then operators to work with this data, exactly that, operators. And finally, a small part related to types, so you can parameterize its concurrency working with the data, which we will be calling spectrums. The main presentation will be focusing on the observables and operators. I don't think that scalars are something very easy to understand as an entry point, but just so everybody understands that this exists, and it's something that when they hear about that, it's like, okay, this is this other part that maybe right now I don't need to touch, but I know that it's not something super. Um, First, then, what are these observables? As we said, these are a set of types representing synchronous data streams. It's like common design pattern, and the easy way to explain it, there are many. It's like when you subscribe to a physical newspaper, or you follow someone on Twitter or on Twitch or on YouTube or anywhere, you do this action, and when there's new content, you receive that. You don't have to worry about exactly what's happening. Just you subscribe to something, and when there's new data, it comes to you. The next question would be why use those observables? As we said, you just subscribe. You don't have to worry about requesting new data all the time. You have a subscription that has a period. It can end or it can be endless, and you keep receiving new data. And finally, you have control on what's happening on this data. So you can do actions specifically if you receive some error, if you receive a new information, or if the subscription tells you this is done, you received all the data. You can work on all that. That's mostly all about observables. I think it's a common design pattern in many programming languages, so I don't think it's something that we need to do a lot. But the interesting part of Rex is the operators part, how you can work with the data that you are getting via observables, and the easiest way to understand that. So, operators are tools to work with this data stream. You receive this subscription, you receive this newspaper, you receive this new information. What do you do with that? An easy way to visualize that is that you have an array of data that is filling over time. So let's see this array. You have a series of numbers, and you do one operation over that and get a different series of numbers. With data stream is the same. Here we have a stream of different clicks, for instance, with the different coordinates. You have one click that is in coordinate 121 and y 350, and a series of clicks that happen between time. You do an operator, remove all the events that the x is lower than 250, and have the same data stream with that filter value. It's just the same, but it happens, instead of being a list that it's all filled, it has been filled with time. It's a variable with time. Continuing with the topic, you have an array that has different kind of operators, and you have the same for observables. Some change name, but most of them are the same. But also, you have time operators. So combine the latest arguments, take arguments until something happens, have a timer, you have the part of the array, but you have the time part also for working with this information. Two very good tools that are provided to understand this are the own Rx decision tree. You have the different options, and you, for instance, select, I have an operator that I want to change a value every time it's calculated through a formula. It tells you, you should use map. And another one that we already saw in the previous slide is RxMarbles, where you can see these kind of diagrams live of different operators. So here we have on top 2 lines of streams, and you do merge, and you see that the final line has the union of the 2 lines. And it's very easy to understand some things, how are happening. And even in the same web page, you can drag the different marbles and check what is happening. Very useful, for instance, when you have something that is like, take the last value in every 30 seconds, and you can see exactly that when you drag 2 values together, one disappears, and if you spread them together, you have more values, etc., etc. So we have these operators. Why use them? You can modify the stream at any point. You can say, take the first value, take the middle value, take the last value, do nothing for the first 20 values, and then start doing something. There's no specific point of action during the stream. You can take one value from the stream, and the stream continues flowing. You are not stopping the stream while working with a value, and then it continues. You can spend 3 hours working with something, and the next value will be there waiting while the stream continues. As we said, the different operators related to time and flow, you can say, change the data source after you have a timeout, something very useful for APIs. You can say, okay, connect to this API point, but if it fails, go to another one as a fallback, for instance. That is something very useful to connecting with async information. And the last one that I think is very important is that all operators are high-level functions. So you have an input and you have an output. And everything that happens in the middle, if it's not returned, it has no side effects. And that's very important with working with all this amount of data, because it's very dangerous sometimes to do some modifications, and then it has a spread effect on the following elements, and you have chaos. But if you know that this function, anything that is not returned, is not having an effect on the stream, it's easier to do step by step and check exactly what is happening with this stream, you know? And finally, just as a small overview, what are schedulers and why to use them? So we said these are ways to parameterize this concurrency. So you can control the timing, say that if 2 things have arrived in the same time, what happens? Do you do one first or the other? Or you discard one task? Its logic of concurrency is abstracted, but you can go exactly to the detail and decide exactly how things happen in parallelization, for instance. You can control multi-threading and all this specific. And finally, it's very good for testing, because if you want to say, I want to test this data, you need to force your data to have some parameters and say, I want to create an observable that emits every 30 hours with this specification. So you can create your own observables to test your own code easily with schedulers. I don't think it's something very useful as a starter, but just when you see a scheduler, you know, okay, this is something related to timing and finer details on concurrency and things related to all that. I think this was a lot of things to work on, so I'll be showing my code, and we will be working through that and try to see what's happening with a live example, which I think that's way better. Now we have these ideas as concepts in our heads. So let's see. I have the simplest project here. Literally, we can see that in the node modules, we have RxJS and tslib, so there's no more extra elements here. We have an index that it's literally importing RxJS, and we have here our code. And I have here an example with the code done, so I don't do any specific mistakes, and I know that this is working. But basically, we will be live updating here. This is being run right now with Parcel, and as we see, there's a series of prints, and we are seeing this printed in the web page. I made this function to print a value and show it on the DOM itself, so we can see exactly more specific messages and then work with the console, but this is more the official output. So as we said, we are working with arrays over time. Let me zoom a bit. So here we have an array of 9 elements, and we will be assigning each element a score and then getting the high score of all these. So this is very simple. You have an array of 10 elements. You go through each element, assign a random value from 0 to 9, and then reduce this function and return the result. We will be doing exactly the same, but working with asynchronous data. So let's change this to console log. Have I selected enough? Oh. So we have the console cleaner. Okay. The first way to work with a lot of data is create an observable from an event that in this case will be clicking on the web. If we click, we will get an event, and that way we can have a lot of events that just happen when we decide. And we will start with the easiest, let me comment that. Just literally, we have this observable, we have a pipe, and we have a tab. Tab is just getting any data and don't modify the stream. So we will get an event from the clicking, and this will enter the pipe. This event will be logged in the console, and this will we will be subscribing to this stream. Now we have this in the console, and every time we click, we get here the pointer event with all the information of the click that happened. And if we click several times, we get all these events endlessly, and we can do all the clicks that we want. The most important thing to start working with Rx is that if you have a stream and nobody subscribed to it, nothing is happening. So even if we do this, now we get no information. Because even if there's a pipe, if nobody opens the faucet at the end and you get the water flow, nothing is happening. So you need to, this would be something that you could assign as a variable and send it to another code that can extend it or do other things. But until somebody is trying to consume the data, nothing happens. This would be like the example of if a tree falls in the middle of the forest and nobody hears, makes a sound. No, because if nobody's hearing it, nobody subscribed to that sound, no information is being sent. Okay, so the first step would be, we can remove this part. The same thing as we do with the list. You have the clicks. So for each click, we are going to do a map and assign a value to this line. So it's literally this thing. It's the same code. I think we could literally copy the array operation just with the different, with a comma at the end, but it's literally the same. You have a map. No, we don't care about the value of the click itself, and we assign a value. If we do that right now, we wouldn't see any results, because even if we are subscribed, this is sent to an empty stream. So at the moment, let's say that we want to say result, and we will log this result. Let's see if this. So now we see that every click we do
has a return value of a result. Next step, so as we do with the array, we do a reduce. In this case, the reduce is called scan, but the concept is literally the same. Just a different naming, but you do the same. You have two values, and you basically are doing a reduce function. You have the accumulator and the current result, and every time that you do a click, instead of getting a result, you get higher value every time because it keeps adding and adding and adding to this accumulator. So this would be literally the simplest way of doing one from the other. But here we are not getting any advantage of using RxJS. At most, like, we are not using anything that requires this time flow. So let's extend it with different information. For instance, we really don't care about this high result unless there's like some final score. So let's, for instance, add another function, which will be a timer, and we will say that we want, for instance, the high score after I don't know, I think that here I have 15 seconds, but maybe it's a bit long. So we have a timer. Let's put it here into 5 seconds. We'll print that the countdown has started, and we can, for instance, subscribe to this notifier. And when this emits, means that the timer has run out, so we can print and say timeout. So we have the countdown started. We can still do the clicks, but nothing has happened, and then we continue doing clicks because this timer, it's a different thing, so we are not connecting the two things. So we will say in our pipe that this will take results until the notifier emits. And now I think it has to refresh a couple of times. See, you can do clicks. Okay, now it's doing the refresh, and after the timeout is done, we don't get more console logs because the stream has closed, and we don't get any more information because everything is closed. But right now we are logging this, but we don't care about the middle results. We just want the final high score. So we don't want to subscribe every time somebody clicks here. We just want to, every time that a score is added, we want to save it in a high score. That's why I created this variable. And when the process finishes, we will emit, well, we will print the high score. We can remove this line at the moment, but basically this is not doing anything to the stream. It just takes this value and saves it in our variable, and then anytime something happens when the stream is over, we will print this value that's saved here. In case something happened before and we didn't update the high score, we would still have this in our variable, and this is something, in this case, this method does have a side effect because this is a variable outside of the scope. So here we need to be careful because right now we are working a bit outside of the stream itself. This is already not a true higher level function because it's having side effects outside of the return. But for this case, let's see if this refreshes. So right now we don't see anything. We are just clicking here, and when it finishes, it says timeout, and we got a high score of 68. So let's add, for instance, something to give us a bit of information of every click that we are doing. We will add here another tab that will tell us that we clicked and what score we got, and we will be counting how many clicks we've done, so then we can print at the end how many clicks have done and which is our score. And this way we can already at least see that something's happening. because otherwise it's a bit weird. So this was a bit of okay. So now we can keep clicking. We get all these scores, and after this finishes, this happened all at the same time, but literally now, yeah, I don't click anymore, and we got 19 clicks and a 77 tags score. This is a bit of, we only have the timer, but basically you could do kind of the same with arrays. So let's add something that's a bit more interesting, which is a throttle. We don't want somebody to come here and start spamming clicks. We had some months ago a competition that David did with the horse race, and you could anybody could click, and basically I added a clicker function on my mouse that did like 300 clicks per second, and basically when the function started, the horse were doing this, and mine then vroom, and did all the
Ah, you were the one.
yes.
Now I understand.
So basically, this is to avoid these things. It's like you can click very fast, but at some point you cannot. There's a limit on how many clicks you can do. So you can put this maybe to something more human, like in this case maybe 500. It's a bit too slow. But if you put 100 milliseconds, at least if you are fast, you get the results. But you cannot put here a script that does zoom and does 300 clicks in 1 second, and you destroy everything else. You know. This throttling and these time things are very useful for these activities that require have a lot of data, have a lot of user interaction. If, for instance, if you are dragging something through the screen, you don't want to send an event every drag. Maybe every I don't know, 10 milliseconds you send one, but you don't need to destroy all the receiving data with thousands and thousands of data. If you have something that is less time sensitive, you can do an accumulator, and every minute you send all the bundle of the data, and you don't have to worry. So you can have different functions to work with this live data that can have a lot of information. So finally, the last thing that I would add, that it's something that usually is harder to see in a project, is we will do some error handling. So basically I decided that if one of the clicks has a score of 0, we will consider that an invalid click. So if something happens and you start clicking and you get a click that has a score of 0, the stream ends because something failed. So how do you handle this error? You had an invalid score here and you cannot click anymore. Let's go back to here one. So the first thing you can do is, if you don't want to see an error in your console, is at the end on the subscribe, you have the first parameter that is the on complete result, but you have the next one which is on error, and you can say, okay, let's capture this error and say finish it with error. And this way, now at least we are capturing the error, and we will get this, but there's still an uncut error.
Yeah, I think it's console.log.
Oh yes.
Yes.
Maybe that's
That's
okay. I think we still need to capture the error in the stream, but I'm not sure. Let's try again. Okay, now we didn't have an error, so sometimes I'm unlucky and I don't get a 0. Okay, so now we see finish with errors, and there's no error because we decided that this was invalid, but we don't care about notifying the user. But we can do another thing. We can say that when an error happens, just try again. And we can put a retry here and say that retry once, for instance. So if you keep clicking and you get a 0, let's see if I can get a 0. Well, I got a timeout first. Let's do it a bit smaller because it's hard to see with too many clicks. And let's put this to 500. I don't know why I'm getting a timeout and then more clicks. more time. So let's just keep refreshing. Okay, so now we got a 0. Let's see if we can get another 0 before it ends. No. Okay, let's try again. Now I'm not getting zeros.
No zeros.
I'm a bit unlucky now. Okay,
Yeah,
so
there
1.
is.
But I'm getting this timeout. I don't know why this is happening so fast. Which it should be happening, but anyway, ignoring this timeout, we got here a 0, and then we got another 0, and that's when the stream ended. So we could add here as many retries as we want, and in case you get an error, you continue with the flow again. You start from the start and try again. You could also do a different flow and say, okay, after there's an error, try something different. But this is just as simple. If you have something that sometimes 1 in 100 million, it fails, and you just need to try again in some time, you can put several amount of retries, and at least the whole stream won't close for just one small error.
Can I have first?
Yeah.
So after retry happens, I will back to line 11.
You will go back here.
Yeah, exactly.
So if we put here, I don't know how I can see this, but well, it's hard to see because as the score is a 0, this is not safe. But if we were to put here a 9, for instance, this 0 score is never safe. So we could put here something just in case that, I don't know, it will never happen. But if the score were to be higher than 9, that would be okay. Somebody's giving us an invalid value, and you start again and ignore that value, for instance. You know, I don't think that throwing an error is the best way for that, but it's just an example because usually error handling is not something that is focused that much. I think that's most of the different things that I wanted to show in the example. So basically, if we go back to the original idea, we had this array of different numbers. We assign a value to these numbers, and then we got the final result. So this was quite simple. And then we have all the different operators. So let's start with the start. From events and notifier are observables. We are creating one from an event specific of the document. Let's click. We could add here mouse drag or anything, but that's stream of data that's coming. Usually in most projects that's an API or something that's external. You don't usually need to create this kind of observables. But timers, for instance, it's something that is very useful. You want, for instance, make a petition request to an API and say, okay, wait for 5 seconds, and if I get no answer, just show an error and say nobody replied. Do not have that infinite loading scheme, for instance. These are a kind of observable that it's very useful to have this kind of limit on connections or something specific, so it doesn't go endlessly. So this would be the observables, and then we have the stream, and all these are the different operators that happen one after the other. And you have all control of the flow. You could, for instance, here change the operator subscribe with a switch map or something different and say, okay, after I get this data, go to another API and grab new data with this new key, for instance, I obtained from another endpoint. So basically it's a flow that continues. You can separate it in two. You could, instead of subscribe, save that as a variable and have two different methods that use this stream. One adds something at the end and one's another thing. You keep constructing everything. But this is basically the two different keys. We could have, I think that timer function, we could have here some kind of scheduling and say, okay, start, instead of start counting immediately, you can put something like start on date specifically or something like that, but I don't think that schedulers are something that we really need at this point. So any questions? Something that we could like add here to see what happens, for instance, or? Good. So mainly that was my idea. I didn't want to go very in deep, just get an overview of the different parts and get all this information. I think that now I could try to show here. Let me find my mouse. This. Oh, where did we go? These websites that I showed before. So for instance, this is the Marvels one, and you can easily say, for instance, the things that we showed today, it's like, let me find something. So for instance, the throttle, you can see that if you have 25 here and you drag this here, now D disappears because it starts every time you get an event, you have a timer. After that, you can say, for instance, let me see if I have something that's interesting here. The example of the scan that we did, you just have every element and you keep updating this final result, and you can, for instance, like reorder things, and you, in this case we don't see much, but we say that the final value is the same one, this 15, but because the results are the same, but we see that the last one is always the same depending on the order. And you have a lot of basic operations that are quite easier to understand with this. So this is just timer, this, and this value is a delay, so it waits 10 seconds and then starts counting every 30, for instance. And I think that's mainly all. My goal was so everybody has the tools to look at this information, but at least the basic concepts are easy to are understood, and you can at least say, okay, I can work with this now that I have a bit of a base to work with that, you know, because it's a very complicated topic. I didn't want to go very in deep on specific details so people would get confused, but at least have an overview of the different parts that you have with this tool. So I think that if everybody has understood this part, I think that I can consider this a success.
Mostly.
Mostly.
Anything you would like to know more of?
Okay, maybe it will be newbie questions. Can you come back to code?
Yes, for sure.
So by the upstairs, when you define when you do from event,
Yes.
by this one function you do observables.
Yes. You're creating an observable from an event. I think that this originally you would do like something like Rx dot observable from event, but now it's directly everything is imported. As you see, let me go back. You have two main of, so everything that comes from RxJS, it's directly more related to observables, and these are the operators. So we only have from event and from timer to create new observables, and the rest are coming from the specific operators. This is usually, unless you are coding something that is related, maybe like if you were to do some game engine or something, you maybe would be more interested in the clicks, but usually you don't use event except for testing something more specific. But here it's an easy way to get data. But from most of the time that I work with RxJS, it's mostly you connect to an API or something, and that's your observable. You don't need to create that. But if you wanted to do something with the user and implement something that's more UI related, and they want to click on things and you get information from those clicks, then would be a way to transform all this data into something that is an observable, and you could have this observable in the core of your application, and every part of the application subscribes to the same observable, so you don't have to process the same data at different types. So you would have maybe one core method that transforms these clicks into the base data that you need. This is a pipe with these transformations that it's core to the application, and then everybody extends a bit and subscribes to the specific results, but you have this shared part of, okay, we need to, all these things like filtering the amount of clicks you can do per second, checking that the click is within the bounds of a specific place, checking that if the click is a click or right click, all this could be in a core part, and then the rest of the application does different things related of, you've clicked here, you click the other part, you've done this, you've done that, for instance. But for me, from my experience, that it's not huge. From event is more something to test things,
Yeah, from event it's clear. I just think about how we use it. So we use implementation in actually it's same library like RxJS. Or for example, we make some GraphQL query. And result of, so it's exactly the same. We just define observables, and when we got data from backend, we just put it in observable, and subscribers receive this data and, for example, draw a component or do whatever. So according like you told, like we just subscribe to something and wait when data inside is changed.
Exactly. Usually most APIs already provide a way of, most APIs already give observables in some way or another, or give promises which you can convert to observables, and vice versa with quite ease. And I think that most HTTP libraries already have some way of generating observables, though from what I see in most libraries, most people have this observable, don't know what to do it, transform it into a promise or something that is sequential, and work with that, because it's like, this is the scary part, and let's transform it something that I know how to work with, and ignore the part that has happened before, But you can do many things that are more efficient with this data if you don't have to make everything stop and here, and it's like, okay, now it's sequential and everything is happening one after the other, and if you have 300 petitions, it's like one waiting for the next one to be consumed, Do we have someone in chat that has asked anything?
People from Twitch, do you have any questions? Or do you have a question? No? Okay.
I think one of the most basic example of implementation of this could be something like loading spinner or something like that, right? So you start the query to the API, and just as it starts, you can set an state of a component to true, and then propagate this state to all the children, and then on finish, you switch it back again. So this will be a real loading state, not something that you manage. Will be really attached and subscribed to the implementation.
Okay.
Good.
You can use it, for example, more powerful usage is like you have a WebSocket. You hear from the WebSocket, you receive a lot of events. You have one stream, and then you create different observables, all deep, and filter by the kind of event. So you can compose streams.
Something very powerful is that it's something that I skip because I think it's more technical, but a lot of tutorial videos speak with separating hot and cold observables, that basically it's one, everybody's getting the same data. So if you do a math random something and somebody consumes an element, they get one, and if the other consumes the first element, they get the same one. And if you have another kind, it's every time that somebody consumes, they get a new kind of data. So depending on the situation, maybe you want that if you have something that is a random number generator, you maybe want that everybody that asks a number, it gets a new random number. But if you're getting something that it's the same, you want that different points of the application are getting the first element, then the second element, and every data is shared until somebody adds the third element. All the application is at the same point, and it starts with the same flow. And if somebody pushes something in that stream, every part of the application is getting exactly the same element at the same time.
So it sounds exactly like a state, like
Yes.
a global state.
Kind of. You could consider that some observables have like a shared state for all subscribers, and others have an individual state for each subscriber, you know. And if somebody asks for next, it's like if you have, for instance, a bowl with candy and somebody grabs one, that's gone, and everybody gets new candy. Or something that is a machine that everybody asks, that's exactly the same, and you have your own specific candy waiting for you that it's the same for everybody, you know. You can have this kind of state within the observable pipe. And that's something that you would do mostly using the schedule techniques and how you subscribe to a specific observables.
There was a Redux RxJS or something like that, an implementation that has been deprecated, I think.
Do you have the pizzas?
Not yet. They didn't arrive yet. So I just ordered like 20 or 30 minutes ago. But maybe we can go to the kitchen. I mean, if we're over, we can just. I don't know if you have any questions there in the chat, so that we can answer now. Otherwise, I would like to thank you, Paul, for the session, for the masterclass for ReactiveX, and yeah, for the ones there, we are gonna finish. We are gonna enjoy the pizzas. I'm looking forward for you to see you around rather than online and share some thoughts together. So thank you very much for attending, and see you in the next one. Bye bye.
I don't think they see us with this